What if the most important moment in the entire 3I Atlas story was not the discovery, not perihelion, and not the jets? What if it was Jupiter? You have been following this object since July 2025. You know the anomalies, you know the debate. But here's the question that scientists are quietly working through right now. Did anything happen at Jupiter that gravity alone cannot explain? Because the post-encounter trajectory data is still being analyzed, the activity measurements are still coming in, and the comparison between where 3I Atlas was predicted to be after Jupiter and where it actually is has not been published yet. By the end of this video, you are going to understand exactly what changed at Jupiter, what scientists are measuring right now, and why the answer to one specific calculation could rewrite everything. Subscribe to Space Aquarius and let's begin. Let's start with what actually happened at Jupiter, because the geometry of this encounter matters more than most coverage has explained. Jupiter is the gravitational heavyweight of our solar system. Every other planet combined does not match its mass. And its zone of gravitational dominance, what scientists call the Hill radius, stretches out roughly 33 million miles from the planet's center. That is the boundary where Jupiter's gravity starts to overpower the Sun's pull. 3I Atlas reached its closest point to Jupiter in mid-March 2026, passing at a distance of approximately 33.3 million miles. That is essentially identical to Jupiter's Hill radius. Now here is why that specific distance matters so much. Any object that passes inside Jupiter's Hill radius, given the right velocity, could potentially be captured into a stable orbit around Jupiter. Any object that passes outside that radius gets deflected by Jupiter's gravity and continues on its way. 3I Atlas passed right at the boundary line. Not well inside it, not well outside it. Right at the line. Scientists calculated that the probability of a random interstellar object threading that needle, arriving at Jupiter's Hill radius boundary rather than somewhere else along the vast range of possible distances, was extremely small. And he raised a possibility that most mainstream astronomers were not willing to engage with publicly. What if that precision was not random? What if 3I Atlas was designed to arrive at exactly that distance? Because at Jupiter's Hill radius boundary, something specific becomes possible that is not possible anywhere else. A small velocity adjustment, applied at exactly that distance, could place an object into a stable orbit around Jupiter indefinitely. Not a temporary flyby, a permanent orbit. And the Lagrange points of Jupiter, the gravitationally stable positions in Jupiter's orbital path where objects can sit with minimal fuel expenditure, would be accessible from that boundary with very little additional maneuvering. That is the open question that the Jupiter encounter left on the table. Did anything change its velocity at Jupiter? The answer to that question is still being worked out from the trajectory data. And that is the first thing that changed after Jupiter. The trajectory itself. Before the Jupiter encounter, scientists had been tracking 3I Atlas using a combination of ground-based telescopes and space observatories. The trajectory data was good but not perfect, partly because the non-gravitational acceleration of the object, the fact that it was being pushed slightly off a purely gravitational path by its own outgassing, made precise predictions difficult. After the Jupiter encounter, the trajectory data became much more precise, because Jupiter's gravitational influence on 3I Atlas during the flyby was enormous and well understood. Scientists know Jupiter's mass to extraordinary precision. They know exactly how much gravitational force Jupiter exerts at any given distance. So by measuring exactly where 3I Atlas was before the encounter, and exactly where it was after, scientists could calculate the precise change in velocity that Jupiter's gravity produced. And then they could compare that calculated change with the actual observed change. If those two numbers match, the encounter was purely gravitational. Jupiter deflected 3I Atlas exactly as physics predicts, and the object is now heading out of the solar system on a predictable path. If those two numbers do not match, something else happened at Jupiter. Something that added or subtracted velocity beyond what gravity alone would produce. That analysis is currently underway. The preliminary data as of late March 2026 shows that 3I Atlas is now on an outbound trajectory toward the Gemini constellation, moving at over 130,000 miles per hour. But the precise comparison between the predicted post-encounter trajectory and the observed post-encounter trajectory has not been published yet. That is the measurement scientists are watching most carefully right now. And it is the measurement that could change everything. Now, let's talk about what the Jupiter encounter revealed about the object itself. Because the flyby was not just a gravitational event, it was also an observational opportunity. The ESA's JUICE spacecraft, the Jupiter Icy Moons Explorer, was already in the vicinity. It had photographed 3I Atlas back in November 2025 from a distance of about 41 million miles, collecting spectral data that scientists are still analyzing. But the March 2026 encounter put 3I Atlas much closer to Jupiter, and therefore much closer to the instruments that have been studying the Jovian system for months. The data collected during and immediately after the Jupiter encounter is still being processed. But here's what scientists already know from the pre-encounter observations that makes the post-encounter data so important. Before Jupiter, 3I Atlas was actively shedding material at an extraordinary rate. The Solar and Heliospheric Observatory had detected a massive cloud of hydrogen surrounding the object after perihelion, consistent with the release of approximately 13.5 million metric tons of water in a single month. The ALMA radio array had detected methanol at levels far higher than any known solar system comet. The James Webb Space Telescope had found deuterium in the water at levels more than 10 times higher than known comets, and deuterium in the methane at levels about 14 times higher than Comet 67P. And the Hubble Space Telescope had documented 3 jets spaced exactly 120 degrees apart, wobbling with a period of 7.1 hours. All of that activity was happening as 3I Atlas was moving away from the Sun after perihelion, with solar heating decreasing. The question scientists are now asking is simple. What is 3I Atlas doing now? Is it still venting gas and dust at the same rate? Is the activity decreasing as it moves further from the Sun? Or is something else happening? Because here's the thing about the Jupiter encounter that most people have not thought through. Jupiter is cold. The surface temperature of Jupiter's cloud tops is about minus 160 degrees Fahrenheit. At the distance of Jupiter from the Sun, solar heating is about 27 times weaker than it is at Earth. For a natural comet, that means activity should be dropping dramatically. The further from the Sun, the less solar heating, the less sublimation, the less gas and dust release. If 3I Atlas is a natural comet, its activity level should be falling off sharply right now. If it is not, that is a significant data point. And the activity measurements from the post-Jupiter observations will tell scientists exactly which scenario is playing out. That is the second thing that changed after Jupiter, the activity baseline. Now let's talk about the third thing that changed, the debris field. Before the Jupiter encounter, scientists published a paper asking whether fragments shed by 3I Atlas could have reached Earth's atmosphere by late March 2026. The calculations showed that marble-sized fragments ejected from 3I Atlas at speeds consistent with normal outgassing could have crossed the roughly 34 million miles between 3I Atlas's orbital path and Earth in the available time. They estimated a maximum of about 34,000 such fragments could potentially intercept Earth. And in March 2026, the American Meteor Society recorded fireball witness counts nearly 3 times higher than any previous March on record. The two biggest events, a 7-ton object over Ohio and a 1-ton object over Texas, were almost certainly unrelated to 3I Atlas. They were too large to be fragments from that object, but the smaller events, the ones that did not make national headlines, are still being analyzed. The directional and velocity analysis that would confirm or rule out a 3I Atlas connection has not been completed. After Jupiter, that analysis becomes even more important, because the Jupiter encounter changed the geometry of the debris field. Before the encounter, the debris shed by 3I Atlas was spreading outward from the object's pre-Jupiter trajectory. After the encounter, Jupiter's gravity has deflected 3I Atlas onto a new path. That means the debris field now has two components: the material shed before the Jupiter encounter, which is still spreading along the old trajectory, and any material shed during or after the Jupiter encounter, which will spread along the new trajectory. Scientists tracking the debris field need to account for both components. And the question of whether Earth will pass through any part of that debris field in the coming months depends on the precise geometry of both trajectories. That calculation is being done right now. Here is where the story stands as of April 2026. 3I Atlas is heading out of the solar system. That is certain. its post-Jupiter trajectory is being refined as new observations come in. The comparison between the predicted and observed post-encounter path is the most important measurement currently underway. The activity level of the object is being monitored to see whether it is behaving like a natural comet that is shutting down as it moves away from the Sun, or something else. The debris field analysis is ongoing, with scientists working to determine whether any of the March 2026 fireball events carry the chemical fingerprint of 3I Atlas. And the full dataset from the JUICE spacecraft observations, the James Webb data, the ALMA measurements, and the Hubble images is still being processed and published. And that data is coming. If this video got you thinking, subscribe to Space Aquarius so you do not miss the updates as the post-Jupiter analysis comes in. Leave a comment and tell me what you think happened at Jupiter. And share this with someone who has been following 3I Atlas from the beginning. They need to see this.